Welcome. My name is Dennis Kucera. I'm the applications engineer from the MPEG product line. I'd like to spend the next several minutes going over the operation and usage of the MTS4000 product. What we have in front of us right now is a couple PowerPoint slides to give us an example of where this product would be used. In the lower right-hand corner, we have the QAM distribution feed going out to the customer base. That would be for people with set-top boxes. And if we work our way back, any of the blue circles that we have highlighted here are access points either for RF, MPEG, or QAM signals, all the way back up to including the ASI ingest from a satellite, terrestrial, or any other types of MPEG feeds that are coming in. So these are going to be our test points for the MTS4000. The MTS4000, seen here on the right side, has a variety of cable connection points, whether it be Cat5, fiber optic, 10 gig, ASI, coax cable for ASI or for RF signals. So there's a variety of different connections that we'll be making use of today as we step through this application. And then on the side we can see that the current configuration right now has a single mode fiber duplex for the IP card on top. We have the two white cables that are jumpers for our ASI in and ASI out, and then below that we also have the capability for additional RF. At the near bottom of the motherboard here, we have a connection for the local area network, which we'll be using today in order to remote desktop in. And then we have a second network interface connection that we'll be using to connect up to a Cisco switch. So we have our Cat5 connection here. We have another Cat5 connection on our main full speed board and an optical connection. So with that, I'll minimize the PowerPoint slides that we have here and start in on the Transport Stream Compliance Analyzer. So here we have the Transport Stream Compliance Analyzer. The first view that we have up after opening up either a file or a real-time signal is the Flex View display. We can configure any four of these quadrants for any of the multiple sets of windows that we have in the analysis view here. Currently I've configured the lower right corner to show me a constellation diagram and all of the RF parametrics on the particular signal here on the local RF feed delivered to our building. And the choices are from EIA 7, I believe it is, all the way up to 850 megahertz. So there's a lot of choices for the QAM signal. We also have our RF measurements here, the signal power level, and then the modulation error ratio, which is like a signal to noise measurement. So we have all of our measurements here. Then the demodulated signal we feed over the ASI jumper, and then the MTS4000 analyzer takes care of looking at all of the program parametrics as well as showing us thumbnails of the information that we're looking at. The lower left-hand corner provides us measurement display, red being the most recent errors, and then the yellow amber ones are errors that have since then gone away and are kept in memory. So the first display that we have in the Transport Stream Compliance Analyzer is our Flex View display. We also have the ability, when opening up this stream, to open up more than just the QAM. We have the network interface card, we have our IP cards, our IP connections, we have ASI, as well as other RF cards if we had them plugged in. If we want to look at more details about this, we could look at, for instance, program clock reference information. So with this, I'll select the first program. And after selecting that program, I can then go in and look at a wide variety of timing measurements. Here we have the overall jitter on the program clock reference, inaccuracies, all well within the band defined by TR101290. We also have other parametrics that we can look at, such as the presentation timestamp and the delta value showing us with the presentation timestamp minus PCR, how many milliseconds each frame is going to be held in memory of a set-top box before it's used, presented, and then flushed out the queue. So we have our minimums and maximums that we're making here, and we can make those on any one of the programs. They're actually all being made in parallel right now, whether we view them or not. And then the graphics can be shown if you want to log into the unit and review it. Any of the measurements that are in error get automatically put into a log file. If we go back to the Transport Analyzer and look at the event log, we have a historical representation of all the problems that have occurred, time-stamped, and then an error message for each one of those. And that information can be exported back to the PC. So that's the first Transport Stream Compliance Analyzer, and this unit can access multiple different ports all in parallel. So with that, I'll leave it running in the background, open up another one that's looking at an ASI signal. In this particular case, we're looking at a signal that could be coming in off of a satellite feed, so our input port now is the ASI. So we have that capability. If we go back to the flex view, we can see that we're looking at a standard definition feed here. So this is an MPEG feed coming in off of a remote ASI source. And similarly, we have the ability to look at multiple connection points again. And in this particular case, we're looking at the GigE port, one of the signals coming in off of the gigabit Ethernet. So these are looking at signals that are coming in live. We also have the ability, because this is a multifunctional box, to be able to generate streams at the same time. So here we have a transport stream player which is playing out over the IP network interface card, and another transport stream player playing out over the ASI port. So this analyzer has the ability to analyze live signals and generate live signals at the same time. Now beyond that, another capability of this analyzer is the ability to remultiplex streams that you have acquired in recent history. So here's an example of the multiplexer application, and this application here, I'll go ahead and close down the most recent file that I opened up, and I will go in and open up a transport stream. This is the most recent one, and what it does is it disassembles and keeps track of all of the individual programs and allows you to individually add or subtract elements that you may deem necessary for your playout purposes. So if you want to take a stream and record it to disk, manipulate it and play it back out, this application, the multiplexer, is opportune for that need. Now the next thing that we have is the VQS1000. This will also look at a file or a real-time feed. Through the real-time, we can select any one of the input ports, or if we're using ASI, through the Transport Stream Compliance Analyzer. And with that, we can look at a live input port, maybe off a satellite. Another possibility is to load a file that was recorded to the hard disk. And in this example here, I'll step through a previously recorded file. And I have two different samples, one of them that was coming in off of a 10 megabit encoder, another one off of a 2 megabit per second encoder. In the upper left-hand corner, we show the video codec that was being used, in this case MPEG-2, standard definition, and the audio, in this case happens to be MPEG-1 layer 2. The lower left-hand corner, we show the decoded video, and in the lower right-hand corner, we show any motion changes, how often black is found, blockiness for overcompression, and also finally audio analysis, looking at levels such as loudness over time. In the top middle, we also show for the live or file signal a variety of different measurements. In this particular case, we're showing the blockiness in green and the short-term loudness in red. So we have how blocky the signal is, and again, depending on the video, the more movement, the harder it is to encode. The more stable the background, the easier it is and less blockiness it has. So that's the impairments on the left. On the right side, we have our audio loudness in LKFS. So this is an overview of the VQS1000, and that's for single-ended testing. So the next thing that we have is the Picture Quality Analyzer. So for those cases where you have a reference file, we can compare the reference against a test file. And in some cases, it may be an uncompressed file that we're going to encode-decode, or it could be, in the example that I have here, this was a recording of a test clip that was coming in at 10 megabits per second on IP, and another clip coming in at 2 megabits. The 2 megabit was essentially a decode and a recode, or a transcode of the original file. And we can see as we step through this frame by frame by frame that the pictures look the same, and the difference is taken down in the lower right-hand corner. So we have the difference in PSNR, we have the difference in picture quality ratings. In the lower left-hand corner, the graph shows how different the stream is. In this case, it's for the picture quality rating. And in the PSNR case, we can see that we have differences that change over time, and this is specifically due to the fact that the signal is changing. So if we were to step forward in time with the Picture Quality Analyzer and look at near the end of the running event, So here we have a mob scene running or a marathon running, and between the 10 meg and the 2 meg, there's quite a big difference. So the difference is shown in white. Black means there's no difference. And if we step ahead in time, we can see that as we transition from the running event, which we're measuring each frame, in this case it's in red or yellow, if we step forward just a slight amount, we'll transition to the water event. Looks like maybe off the coast of Hawaii somewhere. And at this point we can see that the delta between the original and the encode-decode is significantly closer, so there's a lot less white. We can also see here that the measurement, PSNR, has dropped from about 24 down to about 32, so it's getting significantly better. So in the cases where you have a test file and you have access to the original reference, in this case maybe a 10 megabit version, the Picture Quality Analyzer is an excellent tool to perform a delta test or a reference test. Now what I would like to finish up with is another application, the Elementary Stream Analyzer. And with this, for those of you that need to know that your encoded stream can be safely decoded by any MPEG decoder out there or set-top box, this analysis tool, the MTS4EA, will look at each and every individual frame and break it down to the individual codes. And those are seen in the lower right-hand corner here. So every code that's being sent by the encoder is being sent to a prospective decoder. The MTS4EA is stepping through each one of those codes using the international standard and telling you whether it's valid or not. In the upper left-hand corner, we're showing you graphically how many bits per frame are being used. So this is more of a qualitative tool, but it will let you know when you have things such as B frames that are larger than I frames and so on. And then lastly, in the lower left-hand corner, we have our audio information, in this case stereo, that has been decoded. So if you want to perform a lip sync to an event that has some visual reference to it, whether it's a cannon going off or somebody clapping their hands, we can actually look at the individual video frame, look at the loudness, and see how many milliseconds apart they are. So with that, what we've got is a large collection of application software, all available on the MTS4000, and each one of these tools is made available for diagnostics testing, real-time and deferred time, from the transport stream and RF and IP layer all the way down to the video macro block and pixel. Thank you.